Alright, welcome back to solving electrical problems. Now here we have a diagram and we are asked to find resistor 2. And here is resistor 2. We have R1 10 ohms, V1 20 volts, RT equal 50 ohms, VT equal 100 volts, IT equal 2 amperes. Now we can go about finding the R2 in two ways. So the first way that we're going to use is, remember in previous videos we say if we have the total resistance and we have the resistance across one of the resistor, we can take away this resistor 1 from the total to give us resistor 2. So we're going to use that as the first method to find the resistor of R2. So here we have R2 is equal to R2 is equal to RT. Use this formula first. RT minus R1. So here we have RT. Write this properly. RT minus R1 to give us R2. So here we have RT being 50 ohms minus R1, which is 10 ohms, and that is equal to R2. So writing R2 is equal to 50 minus 10, and we are left with 40 ohms. So here now R2 is equal to, let me just scratch it there, 40 ohms. So just keep that in mind. We're going to use the other method of finding R2 to see if we get the same value. Let me draw a line across this just so as not to mix them up. Alright, so the next way of finding R2 is that we would need the voltage across R2. Alright, so we need V2. So let us look at finding V2 first. So V2 is equal to, if we go to the triangle, you cover V is equal to I times R. So we're going to write this formula, I times R. So since we have 2, we put 2 there times R2. Okay, so I2, remember that in a series circuit the current is constant, so this IT is the same as what would be here and what would be there. So we're going to use 2 amperes for I2. So 2 amperes multiplied by R2 2 amperes multiplied by R2. So what we're looking for, no, so this formula could not work because we don't have R2. So this formula is a no. So what we would need to do is to find another method of finding the voltage, because we're looking for V2, the voltage across this resistor. So in a similar way in which you find the resistance of a resistor by minusing this resistance from the total to get that, you would use the same method, since if you add this voltage plus this voltage, it should give you the total voltage, and that is how voltage operate within a series circuit. So let us take out this part of it. That cannot work because we don't have R2. So we're going to look for V2 and we're going to come up with a formula is equal to, V2 is equal to VT minus V1, because we now have V1. So remember, if you add V1 and V2, it should give you the total voltage. So if you minus V1 from VT, it should give you the voltage on the V2 side. So let us do that. So V2 is equal to VT, which is 100 volts, 100 volts, minus V1, which is 20 volts. We end up with 80 volts for V2. So V2 is now 80 volts. So let us write it here so that we can use it as reference. V2 equals 80 volts. Now we have 80 volts and we have the current. We can now use these two values to find the resistance across resistor 2. So let us go ahead and try that out. Space. Try and use as much space as I can. Alright, separate there. So then we are going to now find R2. So using the formula as we had here, going back to the formula here, so if we cover R is equal to V over I, so R2 is equal to V2, using by the 2, divided by I2. Remember now, R is equal to V over I. R is equal to V over I. So because we were looking at the resistor 2, we put 2 there, 2 there, and 2 there. Alright, so this is equal to, so V2, let us go back to the diagram. V2 is equal to 80 volts. Divide by I2, and we remember that the current is constant in the entire circuit, so we use back the IT, which is 2 amperes. So 80 divided by 2 is equal to 40 ohms. So R2 is equal to 40 ohms. So you see, when we use this method, we get R2 to be 40 ohms, and when we use this other method, we still remain with the 40 ohms for resistor 2. So this is how we find resistor 2 using two different methods. So this would be the easier one, but if you think you can do the challenge of finding it using this way, no problem. Thank you for watching. Please subscribe. Have yourself a nice time.